the practice problems video for the section on functions and function notation. Okay, so here's problem number 1. We have the amount of garbage, capital G, produced by a city with population P is given by G is equal to F of P, which means G is a function of P. Okay, so G is measured in tons per week, and P is measured in thousands of people. Okay, so let's look at part A. So before we actually do that let's look at this thing here. We have G is equal to F of P, which means that G, because that's garbage, right? So the amount of garbage, let's just think of it in plain English, right? So amount of garbage depends on, or is a function of P. And P represents population, okay? So that makes sense, right? The more people you have, probably the more garbage you're going to have. So let's look at part A now. So we have the town of Tola has a population of 40,000 and produces 13 tons of garbage each week. Express this information in terms of the function f. So let's look. So we have population is 40,000. So we have 40,000 people here, okay? And we have 13 tons of garbage. So 13 tons of garbage. All right, so let's see how we're going to express this in terms of our variables, first of all. So P is population, right? And P, let's look up here. So P is measured in thousands of people. So how would we represent 40,000 people? That would be P is equal to 40, okay? Because this means 40,000 people in reference to the variable P. Okay, so now let's look at our 13 tons of garbage. So how would we represent this with G? That would be G is equal to, since G is measured in tons per week, we have 13 tons of garbage per week, so that just means G is 13. Okay, so now all we have to do is just stick it into this form here, and we'll be good to go. So that means all we have to do is say G is equal to a function of P, and we're just going to plug in 13 here. So we have 13 is equal to F of, and our P was 40. Okay, so 13 is equal to F of 40. Alrighty, and that's pretty much it for part A. Okay, so let's do part B on the next slide. Okay, so part B says explain the meaning of the statement f of 5 is equal to 2. So here we're kind of going backwards, all right? So f of 5, let's see what that is. So f of 5 is equal to 2. So let's identify, first of all, what are our variables? The thing inside the parentheses is our P, which represents population, and the thing outside is our capital G, okay? So what does this mean on a deeper level? So G equaling 2 means that our garbage, the amount of garbage produced is 2 tons per week, right? Okay, 2 tons of garbage, that is, so of garbage. Alrighty, and then as for our P, P is equal to 5, which when we translate it through what the variable actually means, that means that we have 5,000 people, okay, somewhere in like a city or whatever. All right, so we could say that f of 5 equaling 2 means that 5,000 people, let's just write it in sentence form, right? So 5,000 people produce, according to our function, 2 tons of garbage per week. Garbage, and then per week, okay? And that's pretty much the plain English description of this notation here, this f of 5 is equal to 2 in the context of our problem. Alrighty, number 2. We're going to select all of the following tables which represent y as a function of x. Okay, so this is a little bit different from the examples in the concepts video just because they're vertical tables, but it means the same thing. This column is our inputs, okay? And this column are our outputs. Okay, and the same exact thing goes for B, C, and D as well. Okay, so what we're looking for is a function, whether this is these tables represent functions or not. So that means for each input, for each unique input, we can have only one unique output. Okay, so let's look at A. So we have 0 produces a -2. That's fine. That's the first time we've seen it. Okay, so now we know that that's the set output for that given input. For 3, we get a 1. Okay, for 4 we get a 6. All right, we're moving along. 8 we get a 9, and 3, okay, so we see a repeated input, right? So we just have to make sure it has the same exact output that it had before, and it in fact does. So this means that we have a function. So this is, actually I'll just write yes. Okay, so this is a function. Okay, so now let's look at B. So we have -1 going to -4. That's fine. 2 goes to 3. 5 goes to 4. 8 goes to 7. There are no repeated inputs here, so we don't even have to worry about having different outputs for the same input. So this is going to be kind of, sort of, an automatic yes. All right, so now let's look at C. We have 0 goes to -5, okay? 3 goes to 1. 3 again. We just have to make sure it goes to 1 like it did before, but the thing is, it doesn't. 4 is not equal to 1. So here we have two different outputs, this 1 and 4, for the same input, which is 3. So this is going to be a no. This does not represent a function, okay? All right, and lastly we have D, which if we look at that, -1 goes to -4, 1 goes to 2, 4 goes to 2, 9 goes to 7, 12 goes to 13. Okay, so none of these inputs are repeated, so that means we have a function. So this is going to be a yes. All right, and you might note that on this last part, this part D here, we had two things. This 1 and the 4 both went to gave an output of 2, right? So that means, furthermore, this is just a bonus part, that this function, even though it is a function, it would not be 1-to-1. Okay, so not 1-to-1. Alrighty? We try.